Hello there, geometers. This is Miss Backfish, and I'm here to talk to you about one of the first topics we discuss when we reach our unit on right triangles, and that is the two special right triangles. Now, right now, there's nothing special looking about these right triangles, but I'm going to draw the information in there that makes them special as I'm talking about this. There are two right triangles on which we tend to memorize how the side lengths are related to each other going around the triangle. And it's because those special right triangles, those two particular right triangles, happen to come up in lots of different situations. And we'll talk a little bit about where. But the two special right triangles are are right triangles with angles of 30 and 60 and 90. That's one of them. And the other one would be a right triangle that has two angles that are both 45 degrees. Now remember that when we talked about isosceles triangles, we said every isosceles triangle has base angles that are congruent. So if you have a triangle that has two angles that are congruent in it, that means it's also an isosceles triangle. That's the isosceles base angles theorem converse. So in other words, this is a right triangle and it's also an isosceles. The two legs are the same. Every time you have a 45, 45, 90, the legs are the same. And every time you have the legs are the same in a right triangle, the angles are going to be 45 and 90. So these are my two special right triangles. And that's usually how we refer to them. We call this one a 30, 60, 90, just talking about what its angles are. And we call this one a 45, 45, 90. Okay, and what we do with these is we memorize the ways in which their side lengths are related to each other. And my dog is over here getting hyper. I think they call that the zoomies, so hopefully you don't have to hear that. But first thing I want to talk about here is the 30, 60, 90. The 30, 60, 90 has a little bit more going on in it than the 45, 45, 90, so let's go ahead and get with that one going first. Okay, so one of the other things we've talked about with triangles, excuse me, okay, dog dealt with. If she barks again, I will show you her picture. So that's something to look forward to, right? Okay, so let's talk about, in every triangle, we talked about earlier in this course, generally, we talk about the fact that the smaller legs or the smaller sides of any triangle are across from the smaller angles. And the biggest sides are across from the biggest angles. That's one reason why in a right triangle, the hypotenuse is the longest side, or really is the reason why. Is because the right triangle, the 90-degree angle is the biggest one. So if you go across from the biggest angle, you get to the biggest side. So that's the first thing we do in a 30, 60, 90 is we need to look at where's the 30, where's the 60, where's the 90, what's my shortest leg, what's my longer leg, and what's the hypotenuse. Well, we just talked about this is the hypotenuse. Remember that the two sides that meet together at the right angle, those are the legs. The hypotenuse is directly across from that. Okay, now we have two legs. One of them is shorter and one of them is longer because one of them is across from a 30-degree angle and one of them is across from a 60-degree angle. So we generally call this, in this particular triangle, the short leg, and we call this the long leg. Okay, so now in every 30, 60, 90, here is the relationship that is true between all of these particular things. Let me call the short leg X. All right, if the short leg is X, then the long leg is going to be whatever that X value is times square root of 3. That's just the relationship that always happens when you have a 30, 60, 90 triangle. Also, whatever the short leg's length is, whatever your X is, that number times 2 gives you the hypotenuse. So you notice that we're doing everything else in terms of the short leg. With a 30, 60, 90, you always want to start with the short leg if possible. And if it's not where you're starting, then it's the first thing you find next. So if you don't start with the short leg, if you're not given the short leg, it's the first thing to find. Because then we can use these rules. So going from, another way to draw this, going from the short leg to the long leg, I'm going to multiply times square root of 3. That's not meant to be an X, that's a multiplication symbol. And going from the short leg to the hypotenuse, I'm going to multiply times 2. So then what does that mean if I'm going in the other direction? Let's see if this color will work for me. If I'm going backwards, if I'm starting with the long leg and trying to get the short leg, The opposite of multiplying times square root of 3 is dividing by square root of 3. And again, if I'm starting at the hypotenuse and going to the short leg, the opposite of multiplying times 2 is dividing by 2. So notice that I don't ever go from here to here. I don't ever go from the hypotenuse to the long leg or the long leg to the hypotenuse. If I start with anything other than the short leg, the first thing I do is go back to the short leg. All right, let's look at that maybe drawn a little differently. Let's use an example of, in this particular 30, 60, 90, where's the short leg? That's the first thing I need to know. Here's the short leg. Here's the long leg. Here's the hypotenuse. So what if I knew that the short leg was 2 centimeters, 2 inches, whatever, 2 units? Okay. Then to get from the short leg to the long leg, I'm going to multiply times square root of 3. So my answer for the long leg, or my length of the long leg, would be 2 times the square root of 3, or 2 root 3. To get from the short leg to the hypotenuse, I multiply times 2. So 2 times 2 is 4. So one thing you notice here about a 30, 60, 90, not only is one of the acute angles twice as big as the other, but because of that, the hypotenuse is twice as big as one of the legs. So anytime you see a right triangle where the hypotenuse is twice as big as one of the legs, it's going to be a 30, 60, 90. Now, one of the places that we tend to use 30, 60, 90s that they are very helpful is with equilateral triangles. If I have an equilateral triangle, and I'm sorry, it's a poorly drawn one, that means all the lengths, all the side lengths are the same, equilateral. So like 12, 12, 12, right? Well, all of the angles are the same also. So all of the angles in an equilateral triangle, 180 divided by 3, they're each 60. 60 degrees, and 60 degrees up here. Okay, I'm not going to write it up there because I want to point out that if I wanted to find the area of this equilateral triangle, I would need to know the height. So sometimes I want to find the height. If I wanted to find the height, then look what has happened. I've divided my equilateral triangle into 2 congruent smaller triangles, and the 60 that's up here is now 30 on each side. So what do I have? I have a 30, 60, 90 over here and a 30, 60, 90 over here. This would be 6. This would be 6. Okay? The short leg is half the hypotenuse, and also I've divided it 12 into 6 and 6. And that means my altitude of this triangle, or the height, is the long leg of a 30, 60, 90. So just like over here, we took the short leg and multiplied times square root of 3. This is going to be 6 root 3. The short leg times square root of 3 gives me the long leg. So I just wanted to go ahead and point that out, that equilateral triangles rely on this. But let's do a few problems with 30, 60, 90s, starting in different places, because you know, you might start with the short leg sometimes, start with the long leg sometimes, start with the hypotenuse sometimes. Now notice first, I did not label this 30, 60, 90. I just said 60 and 90. Well, if you have a right triangle with a 60, the other angle has to be 30. Same goes over here. If you have a right triangle with a 30, the other angle has to be 60. So let's start with this one. And let's suppose that I am given this length. In every right triangle, it's a great idea to first locate the hypotenuse. And in this one, my hypotenuse is the side that I just labeled. It's across from the right angle. This is my hypotenuse. So I'm starting from the hypotenuse. Now I need to figure out which one is the short leg and which one is the long leg. Well, here's the 30. So across from the 30, not touching the 30, not one of these two sides, this one here or this one here, but across from it, opposite it, that's the short leg. So here's my short leg, and here's my long leg. Now when I say long leg, remember I'm saying the longer of the two legs. It's not the longest side of the whole triangle. The hypotenuse has that honor. It's just the longer of the two legs. So, okay, we have a hypotenuse of 18. Our rule says that the hypotenuse is the short leg times 2. So if I want to go backwards, I divide by 2 and I get a short leg of 9. Hypotenuse divided by 2 gives me the short leg. And we could write that if we wanted to. Hypotenuse divided by 2 equals the short leg. And then the short leg times square root of 3 gives me the long leg. So that's the long leg. Short leg times square root of 3 equals the long leg. All right, so that's another way of writing out those rules. All right. Next up, 30, 60, 90. This has to be 60. What if I'm given the long leg? This is the most complicated one. Let's suppose that I am given a long leg that is, well, the easiest type of long leg to be given in terms of length would be if it's something like this. If I have 5 root 3 as the length of my longer of my 2 legs, and I need to go to the short leg, that means dividing by square root of 3. All right, from long leg to the short leg is dividing by square root of 3. From short leg to long leg would be times square root of 3, long leg to short leg divided by square root of 3. All right, so one thing I kind of like to write out sometimes just to help me remember these rules is that in a 30, 60, 90, if I'm going from short to long or long to short, the key number is square root of 3. If I'm going from the smaller to the bigger, I go times square root of 3. If I'm going from the larger to the smaller, I divide by square root of 3. So in this particular one, I'm dividing by square root of 3, and it's really a nice, clean answer with this. Because there was already a root 3 in my length, when I divide by root 3, wow, I get 5. Those just cancel. And then the short leg times 2 gives me the hypotenuse. All right, so let's go ahead and write that the way we were doing that in just a second ago. The relationship between the short leg and the hypotenuse is all hinging on the number 2. If I'm going this direction from short to hypotenuse, it's times. From larger to smaller, it's divided. Okay? Draw a little box around that. But what if it's not such an easy number here? What if instead I have the number 8 for my long leg? So I have to divide 8 by square root of 3. Well, that's when life gets a little bit more complicated, quite frankly. Okay, because if I divide by a radical, because I'm going to divide 8 by square root of 3 to go to the short leg, dividing by a radical puts a radical in the denominator, and you're not allowed to leave it like that. So you have to do what's called rationalizing the denominator. And that means basically I just multiply by whatever the radical is over itself. And that will give me 8 root 3 over, what's square root of 3 times square root of 3? It's just 3. That's how square roots work. Square root of 3 times square root of 3 is 3. Square root of 5 times square root of 5 is 5. Square root of 172 times square root of 172 is 172. So now I don't have a radical in the denominator, so that's an acceptable answer. So that would be my short leg. I was going from the long to the short. I divided by square root of 3. I just had to write the answer in a way that it's allowed, because we're not allowed to leave radicals in the denominator. So now here's my short leg. This was my long leg. Here is my short leg. If I want to go from the short leg to the hypotenuse, the number I deal with is 2. If I'm going from smaller to larger, I will multiply times 2. So multiplying this times 2, it's kind of a cool trick. When you multiply this fraction by 2, it's not really a trick, but kind of neat how it works out. Times 2 is the same as saying times 2 over 1, because that's what 2 is. So really, only the numerator is getting multiplied by 2. The denominator is going to stay the same because it's being multiplied by 1. But not only that, when we multiply things with radicals, numbers that are outside the radical can multiply together, and numbers that are inside radicals can multiply together. But you can't go back and forth between the two. So the 2 is not going to have anything to do with this radical number 3. Okay, the 3 under the radical. They cannot interact. The 2 can only interact with the 8. So really, the only thing that gets infected Affected, the only thing that gets affected at all when I multiply this by 2 is that 8 out front. So this is what I get for my hypotenuse. All right. Last but not least, I want to show you one where the, and again, from the long leg, because the long leg, starting with the long leg is the more complicated way. If you start with the short leg, you just follow the rules. If you start with the hypotenuse, you take hypotenuse divided by 2, and then you got short and go from there. All right, so here's my 30, here's my 60. Let's suppose that the long leg is, let's say it's 12. All right, now from long leg to short leg, I'm going from big to small, so I have to divide by square root of 3. So 12 divided by square root of 3. Well, we can't leave it like that. We have to rationalize the denominator, multiply by square root of 3 over itself. And on top, we get 12 times square root of 3. On the bottom, we get just a plain 3. Here's why this one's different, is because these are both outside of the radical, so they can interact, and 12 divided by 3 can be simplified. 12 divided by 3 is 4. So that's what I get for this. The short leg here is going to be 4 times the square root of 3. So this was the long leg, this is the short leg, and now I can find my hypotenuse. From the short leg to the hypotenuse, remember, the rule is use the number 2, and I'm going from small to big, so I multiply by 2. If I multiply this by 2, the 2 and the square root of 3 can't interact. I can't do anything between the 2 and the 3, but the 4 and the 2 interact. So that becomes, whoa, that's a 3, sorry. 8 times the square root of 3. It just basically doubles the number out front. And that's 30, 60, 90s. All right, so from there, we need to talk about 45, 45, 90s. That's the other type of special right triangle. Now, these are a little bit simpler just because of this. We said if they're 45 and 45, if two angles are the same, then two sides have to be the same. So really, I don't have 3 different sides. I have 2 that are the same and then 1 that's different from them. Okay, so let's look at the rules for 45, 45, 90s, or really it's just one rule. Let's suppose that my 45, 45, 90 has a leg of length 3. Well, we just said a 45, 45, 90 is a right isosceles, so both legs have to be 3. Both legs will always be the same in a 45, 45, 90. That's never going to change. Now, what I have to do is I have to get from the legs to the hypotenuse. And so it really doesn't matter which one I go from, they're the same. But going from the leg to the hypotenuse, in a 45, 45, 90, basically the rule is I multiply times square root of 2. And I'm going to use the dot there. Multiply times square root of 2. Now, not square root of 3. Square root of 3 was what I used for 30, 60, 90s, remember. This is square root of 2. Now, I can actually convince myself of this. I can actually prove it if I have a, and I'm just going to, it's not technically a proof because I'm using numbers, but I have 2 sides here. So I could just use the Pythagorean Theorem. So leg squared plus leg squared equals hypotenuse squared. That's 9 plus 9 equals the hypotenuse squared. The hypotenuse squared is 18. And then I take the square root of both sides. And what I'll get every time is 3 times the square root of 2. If you're using a multi-view calculator like this, it will do that calculation for you, that's simplifying the radical. If you're not, it's not that much longer. The way to simplify a radical like this is we ask ourselves what perfect square is a factor of 18. Perfect squares are the numbers we get when we square a whole number. So 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3 is 9. 16 is a perfect square because 4 times 4 is 16. 9 is the perfect one we want. 9 goes into 18 2 times. The reason we're doing this is because 9, square root of 9 can come out. Square root of 9 is just 3. And so that's how we get this answer. So this will be 3 root 2. Now, if short, or we don't have a short leg and a long leg here. We just have a leg. This is a leg, and this is a leg, and they're both the same. So there's not a short one and a long leg. And this is the hypotenuse. So going from the leg to the hypotenuse, we said we're going to multiply by square root of 2. That means going backwards, hypotenuse to the leg, we would divide by square root of 2. Okay, so let's write that on here to kind of just remember all of our rules in one place. If we're dealing with a 45, 45, 90, the only number we're going to work with is square root of 2. Because this is the only thing we need to do. Either go from the legs to the hypotenuse or the hypotenuse to the legs. There's nowhere else to go. Both legs are the same. So to go from a leg to a hypotenuse of a 45, 45, 90, we use the number square root of 2. If I'm going from the smaller, which is the leg, remember hypotenuse is always the longest. So if I'm going from the leg to the hypotenuse, I need to get bigger. So I multiply times square root of 2. If I'm going from the hypotenuse, which is the biggest side, and need to get smaller going toward leg, then I divide by square root of 2. So let's just do a couple more of those. How about this? Triangles that are drawn this way sometimes trip people up. Okay, where's the hypotenuse? It's down here. Remember, the two legs meet at the right angle. And if you have trouble with that, if you notice yourself getting tripped over that, then go ahead and label them. Take the time to be intentional and think about, these are my legs because they meet at the right angle, which means this is my hypotenuse. Okay, so let's suppose that I am given a hypotenuse of 5 and asked what my legs are. Well, to go from the hypotenuse to the leg, I'm going from larger to smaller, so I'm going to divide by that number, square root of 2. So 5 divided by square root of 2, and again, it's not okay to leave radicals in the denominator, so I need to rationalize. And also, again, if you have one of these calculators, it'll do that for you. I'll show you in just one second. On top, I get 5 times square root of 2. On the bottom, square root of 2 times square root of 2 is just 2. So my legs are 5 root 2 over 2. Both of them are, because remember, they are the same. They are congruent. And I promised you I'd show you this. Sorry, my light is not the best. I need to work on the lighting in here. If I take 5 and I want to divide it by the square root of 2, and I could do it as a fraction, or I could just do division. 5 divided by square root of 2. Look what I get. I get the same. I get a very blurry one, but I get the same thing that I got over here. All right. Last thing I want to point out about a 45, 45, 90 is that every single, this is the most common application, every single time I have a square. If I draw one diagonal in my square, just one, doesn't matter which one. In other words, if I connect these 2 points, or instead, if I connect these 2 points, then I just cut the square into two 45, 45, 90s. So sometimes you'll be asked questions about the diagonal of a square, and you have to know that I can use a 45, 45, 90 triangle to figure out what I need. Like for instance, maybe they would tell me one side of the triangle, one side of the square is 10. And they would ask me what's the diagonal. Well, if this is 10 and this is 10, then I would do 10 times square root of 2 to get the hypotenuse, and my hypotenuse would be 10 square roots of 2. Okay, but let's do one a little bit more complicated. What if they told me the perimeter of the triangle, I keep saying triangle. What if they said the perimeter of the square was 28 centimeters, and they want me to find the length of the diagonal? Well, I have to think about what it means that the perimeter of the square is 28 centimeters. Perimeter means all the way around. There are 4 sides. So if I'm adding up all 4 sides and getting 28, then 28 divided by 4 will tell me what one side length is. Okay? And then if I know the side length of a 45, 45, 90, I can multiply that number times what? Square root of 2 and get the hypotenuse. So the length of the diagonal would be 7 root 2 centimeters. And that would be my answer. Okay, let's do one more like that that's a little bit more challenging. What if you're told the diagonal of a square has a length of 14 inches, and you are asked for the area of the square. Diagonal of the square is 14 inches, and you want the area. Go ahead and pause the video and try that. Okay, unpausing. 14 is the length of the diagonal, which means it's the hypotenuse of a 45, 45, 90. If I want to go from the hypotenuse to the leg, I'm going to divide by square root of 2. So 14 divided by square root of 2, which is going to give me 14 root 2 over 2 when I multiply both top and bottom by square root of 2 the way I have been doing. And then 14 over 2, that simplifies, so I will just get 7 times the square root of 2. So this is 7 times square root of 2, and this is 7 times square root of 2. Then I need to think about, how do I find the area of a triangle? I don't know why I keep saying triangle. Of a square, the area of my square. Well, the area of any rectangle is the length times the width, and a square is just a rectangle where the two sides are the same. So this times this, or the side length squared. So 7 root 2 times 7 root 2, or you could say that's 7 root 2 squared. And let's go ahead and work this out. This is the same as saying 7 times square root of 2 times square root of 2. A lot of times people have trouble squaring one of these, so let's just break it down. 7 times 7 is 49. Remember that any square root times itself is just the number, so that's just 2. And 49 times 2 is 98. So 98 square inches would be my area. And that is all I have to tell you about 45, 45, 90 triangles. That's right. I finally used the right word. Okay, I started to correct myself again. 45, 45, 90 triangles indeed. Here is my overview of the rules. If you're going from the smaller to the larger, which means left to right, you're multiplying. If you're going from the larger to the smaller, which means right to left, you're dividing. Let's go ahead and write that. If you're going this way, it's times. If you're going this way, it's divided. But it helps to think about whether you're getting bigger or smaller. And again, there's my two special right triangles. And I did promise you if the dog barked again, I would show her to you. And there she is, the barking dog herself. I hope this video has helped, and I appreciate your coming, and I will see you later.